you see my screen?
Yes.
In the last class, we were studying that what are isotopes, right? And some isotopes are radioactive, right?
Yes.
So radiations, these radiations which comes from the radioactive elements, they can harm us. If the radiation from radioisotopes, it gets into our body, it will kill our body cells. Okay, at a large dose, it causes radiation sickness. Victims vomit a lot, they feel really tired, their hair falls out, their gums will bleed, and they die within weeks. Even small doses of radiation over a long period, it will cause cancer. Is it clear?
Yes.
Okay, write it down.
Okay.
Now we'll study some of the uses of for radioisotopes. The first use we will
I'm
study
done.
to check for leaks. Second use we will study to treat cancer. And the third use we will study to treat germs, to kill germs and bacteria. That means these radioisotopes, they are harmful because they provide harmful radiation, right? You can see here that a large dose it can cause radiation sickness, even the person can die also. But what are their uses? It checks for leaks, to treat cancer, and to kill germs and bacteria. So first is here to check for leaks. So write down the heading uses of radioisotopes. So engineers, they can check oil and gas pipes for leaks by adding radioisotopes to the oil or gas. Okay, so if there is any leakage, there is an instrument called Geiger counter. It detects the radiation outside the pipe. If radiation is there, that means there is a leak. So radioisotopes which are used in this way, they are known as tracers. This instrument you can see, this is your Geiger counter. So why we use it? We use it to check for radiation using a Geiger counter. The meter gives a reading and you may also hear beep sound. So if it is beeping, that means your radiation is present outside the pipe. And we can easily assume that yes, our oil and gas pipelines have a leakage. Is it clear?
Yes.
Write it down. Uses of
Okay.
radioisotopes.
Finished.
Cancer. So radioisotopes, they can cause cancer also. So see that they can cause cancer also, but they are used in radiotherapy also to cure cancer. Why? Because the gamma rays in radiation of the radioisotope, it can kill cancer cells more readily, more effectively than healthy cells. So which isotope we use to treat cancer? Cobalt 60. It is important that we use cobalt 60 to treat cancer. The beam of gamma rays is aimed carefully at the site of the cancer in the body. So we can use our radioisotopes to treat cancer by radiotherapy. From radiotherapy, gamma radiations emit, and these gamma radiations, they can kill cancer cells more effectively as compared to healthy cells. And which isotope we use to treat cancer? Cobalt 60. Clear?
Yes.
Write it down.
Okay. Can I use the washroom?
Yes.
Okay.
Please let me know when you come, okay?
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm back.
done writing this to treat cancer?
Yeah, I wrote it down.
The third use is to treat germs and bacteria. This is your third use of the radioisotope. That gamma rays, they can kill germs too. So the gamma rays are the rays which emit from your radioisotope. So they are used to sterilize syringes and other disposable medical equipment.
Yeah.
They also kill the bacteria that causes the food to decay. So in many countries, foods like vegetables, fruit, spices, and meat, they are treated with a low dose of radiation so that the gamma rays can kill the germs which are present in them. And which isotopes are used in treating germs and bacteria? Par-60 and cesium-137 are used for this. Okay? So this is very theoretical. You have to learn all these things. Write it down.
Okay. Done.
So here, now let me tell you how to write down the electronic configuration for an element. So this is an element which is called as lithium. Okay, this is your lithium. This is your atomic number. Basically, atomic number should be written on the lower side, right? It is incorrectly written here. So if I tell you to write down the electronic configuration of lithium, so how will you write? You should know the atomic number. That's why I am asking that you should have your periodic table with you. Okay. So lithium atomic number is 3. Now if I ask you to write down the electronic configuration, so you will write 2, 1. Why? Because I already told you about that in the first shell only 2 electrons can come. And in the next shell, the first shell is called K, L, M, N. Okay. In the first shell, you can have 2 electrons. In the second shell, 8, 18, 30. So this you have to remember. But in your syllabus, we will read it like this, that in the first shell, you can have 2 electrons because every element wants stability, right? So every element wants to complete octet. So if outer element contains 8 electrons, then it is stable because it is the configuration of a noble gas. Okay, it is 8. That means it is completely filled. So if I ask you to write down the electronic configuration of lithium, it is 2, okay.
Yes.
So can you write it for all the other elements?
Should I write this down?
For lithium, write this down.
Okay, okay. Like
Here you can see that in the first shell you have 2 electrons and in the second shell you have 1 electron.
What? What did you say?
In the first shell you have 2 electrons, right, for lithium. This is the atom of lithium. And in the second shell you have only 1 electron. So it is 2, 1.
Okay, okay. Done, teacher.
If I ask you to write down the electronic configuration for sodium, Na is sodium. So please remember the names of the first 20 elements. This is your homework. You have to remember the name of first 20 elements from the periodic table.
Okay.
So it is your sodium. Its atomic number is 11. So what should be the electronic configuration? In the first shell, 2 electrons. In the second shell, 8 electrons. And in the third shell, 1 electron. You can see 2 plus 8 plus 1 is equal to 11. You cannot put 3 electrons in the first shell because the maximum capacity to hold electrons in the first shell is 2 only. You cannot put 9 electrons in the second shell because the maximum capacity is 8 only. After 2, 8, you have only 1 left. So see the structure of atom. In the first shell, 2 electrons. In the second shell, 1, 2, 3, 4, 5, 6, 7, 8 electrons. And in the third shell, 1 electron. Clear?
Okay. Yes.
Write it down.
Okay. Done.
So I think that's enough for today's class. So what
Yes.
what your homework is that you have to